Hello, geometry students. We're going to start our next unit on rigid motion. Okay? You could also consider this unit to be on transformations. Okay? Now, think about what the word transformations mean. Maybe think about the movie Transformers. Okay? A transformation means that something changes. Okay? There are four, you could almost think of it as 5 different transformations, okay? All right. These are the transformations, okay? And you have this page. So I'm just going to basically summarize these notes that are given to you. All right? There are 4 different types of transformations. You could do a translation, okay? And this is not translating from one language to another. A translation is basically a shift or a move, okay? Or a slide, basically. So if you look, the bunny rabbit slid from here to there, okay? The second type of transformation or rigid motion is a reflection, okay? If you look, here's your bunny, it reflected over this line, it basically flipped, right? So reflection would be a flip. The third type of transformation is a rotation. Okay, and if you rotate something, it is a turn. All right? And then the last one is a dilation. Okay, basically a dilation, when they talk about a person's pupils dilating, basically they get bigger. So a dilation is a change in size. All right, and then there's something also called the stretch. Okay, but we're not going to get into that a whole lot now. Basically, the first 3, translation, reflection, rotation, those are called a rigid motion. Okay, something that is rigid does not change size or shape. It's rigid. Okay, can't be distorted. So when you shift, slide, when you flip, when you turn, the size and the shape of the figure remains the same. It does not change size or shape, right? So the two figures are congruent. When you flip, the 2 figures are congruent. They're equal. They're the same. When you turn, they're the same. But when you do a dilation, the shape is going to get bigger or smaller. And so since the shape size changes, the size changes, this is not rigid. Okay? And basically that's what this down here just summarizes that again. Okay? Now, some vocabulary that you might see. Pre-image is the original shape, the original picture. The new shape is called the image. Think about when you look in the mirror, what you see is called the image. All right, so the new figure is going to be the image. All right, so we're going to just go through and try to identify some transformations here, okay? So if you look, these are quick. Here's the original, the pre-image, okay? Here's the image. All right? Think about it. Is this a rigid motion or not a rigid motion? Okay? Remember, if it's rigid, it's got to be the same shape, same figure. It's congruent. This obviously got bigger, so this is not a rigid motion. Okay? You could call this would be a dilation. All right? But if you look at it, see how the height's the same? So in reality, it really should be a stretch because it's stretched out this way. All right? We'll call it a dilation for now, but it really should be a stretch. Okay? All right, the second one. All right, look at it. Here's your original figure. Here's your new one. Think about what happened here. All right? All right, this basically turned. So this is a rotation, right? It turns sideways, and since the 2 figures are the same size, same shape, that's a rigid motion. All right? Why don't you pause the video and then take a look at the rest of these, try to come up with those, answer these next few questions. All right? All right, assuming you pause the video, you unpause it. Here we go. All right, the next one. Okay, if you look at it, here's the original. The eyes are pointing to the right. Here's the image. Eyes are pointing to the left. It looks like it flipped. Okay, same size and shape, rigid motion. Okay, it flipped, so it's a reflection. You look at the next one. Okay, think about what's going on here. Here's your original. Here's your new one. It got bigger. So this is not a rigid motion. This one's actually definitely a dilation because it got bigger. The other one on the first page was more of a stretch. All right, next one. Here's our original. It's up here, then it's slid down here. All right, it's a slide, so it's a rigid motion because the two shapes are congruent, they're equal, but it shifted, it slid, it moved, whatever you want to call it, they all mean the same. That's a translation. All right, and then lastly, if you look at this last example, here's the original, here's the new one, okay? Now, dilation does not mean necessarily gets bigger. A dilation could get smaller. So basically a dilation means it changes sizes. It could change to get bigger, or it could change to get smaller. Since the size changed, it's not a rigid motion, and again, it's a dilation. All right? All right. All right, now we're going to get into, that was like introductory, so now we're going to start to talk about the first transformation, the first type. Right, and remember, transformation means to change. So the first one is a reflection. All right? So, if you reflect an object, okay, the size and shape are going to be the same. It's rigid. Okay? So, the distance is preserved. So, the sides that correspond on the one shape are the same size as the ones on the other one. The angle measures are going to be preserved. So basically what this means, corresponding sides and angles are congruent. They're equal. All right? Collinearity is going to stay the same. So if two sides are linear, they're going to stay linear in the other one. And if it's going to be parallel, right? You'll have, if two sides are parallel, they're going to remain parallel. What changes is the orientation. That's what changes on a reflection. Now, orientation means the order. So if you do a reflection, the order is going to flip around. All right? All right, you're going to see that, how the order changes when we do some examples. All right? All right, here we go. Pause the video for a minute. Take that all in. All right, and here we go. All right, we're going to reflect a figure in the coordinate plane. Okay, today we're going to reflect over the x-axis and over the y-axis. Okay, tomorrow we're going to do some other reflections. All right, these are quick. All right, here we go. Exercise 1. It says graph this triangle. To save time, I graphed the original already. Okay, so this is the pre-image. All right, then we're going to graph and state the coordinates of the image after the following transformation. A reflection over the y-axis. Okay, so this lowercase r is for reflection. We're going to do rotations, and the difference is rotations are going to be a capital R, uppercase. So if you see lowercase, this is telling me a reflection over, in this case, the y-axis. All right, a reflection's really simple. you're going to count from each vertex to the line you reflect over. Okay? So in this case, we're reflecting over the y-axis, which is the vertical axis. Remember, the x-axis is the horizontal axis. All right, so look, D is on the y-axis. So the distance from D to the y-axis is 0. So that's not going to move. It's going to move 0. Same thing with F. But if you look at E, count, all right? I'm on E, and I'm going to count. 1, 2, 3. The distance on the other side has to be the same. So then I got to go 1, 2, 3 to the other side. That's going to be called E prime. It's like an apostrophe mark. You got to put that little prime there. Okay? Let me zoom this in a little bit. Okay? D is going to stay in the same place. That's D prime. F is going to stay in the same place. That's F prime. And then you're just going to connect that's your new figure. And if you look at it, it flipped over. Okay? See how it flipped? It's a mirror image. Okay, now check this out. Remember we said distance is preserved? If you look at DE, the distance for DE is 1, 2, 3. This one should be congruent. If I count E prime, D prime, 1, 2, 3. This distance, DF, was 1, 2, 3, 4. It's the same. So, size is preserved. It did not change size. All right? But the order changed. See how D is on the left, E is on the right? Well, now it flipped the other way. See how D is on the right, E is on the left. So that's when they say orientation changes, the order changed. It went from D to E, now it's going from E to D. The order changed. All right, now I'm going to look at the coordinates. D prime is still 0, 6. E prime is left 3, so that's negative 3, and up 6. So the new coordinate, E prime, negative 3, 6, and then F prime stayed the same. All right, so the bottom line is, what did you notice? Okay, D and F stayed the same, so let's look at E. See how the numbers are the same? They're both 3 and 6. But when you reflect it over the Y, the X value changed. Okay? So, what rule? When you reflect over the Y-axis, basically you're going to switch the sign on the X coordinate. So, if you have a point, XY, and you reflect it over the Y, it's going to become negative XY. The X value is going to switch signs. The Y values are going to stay the same. All right? It says list all the corresponding angles and sides. That's what I was talking about before. Corresponding angles and sides are congruent. So what I mean by that is angle E is congruent to angle E prime. This angle is congruent to this one. They correspond. Angle D is congruent to angle D prime. Angle F is congruent to angle F. But then also the corresponding sides are equal. So side ED is congruent. Remember we said it was the same distance as DE. DF is congruent to D prime F prime. And finally, EF is congruent to E prime F prime. Okay, bottom line is corresponding sides and angles are congruent. All right, I'm going to do one more example because this video is getting kind of long. And then I'm going to have you try the next 3 examples on the next page. And then that's going to wrap up today's lesson. Okay? All right, number 2. This is a reflection over the x-axis. And again, to save time here, I graphed the original for you. Okay, see, there it is. All right, this time, they want us to do a reflection over the x-axis. So we're going to count from each point to the x-axis. And then we're going to continue in the opposite direction, right? So here we go. This time, this is our x-axis. So from each point, we're going to count. A, if you notice, is one below the x-axis. It's got to flip, so it's going to have to become one above the x-axis. This is the same distance from here to here, there to there. That's A prime. Doesn't matter what order you go in. I'm going to do C next. I'm going to count. C is 1, 2, 3, 4, 5, 6. And then it's got to be 6 in the opposite direction. So right now it's 6 below. Now it's got to be 6 above. 1, 2, 3, 4, 5, 6. That's going to be C prime. And then B prime is also 1, 2, 3, 4, 5, 6. B is 6 away. B prime is going to be 1, 2, 3, 4, 5, 6. All right, and if I connect the dots, all right, you should see that it's the same triangle. It's just flipped around. I'm going to put one of the coordinates here so we could compare these. Check this out. C was 4, negative 6. Now, if I look at C prime, it's 4, positive 6. Notice how the X remained unchanged, but the Y switched signs. And again, what I was saying was, if you look at this, C is 6 below the x-axis, and it's got to be the same distance on the opposite side. C prime is 6 above the x-axis. Same thing with A. A is 1 below, A prime is 1 above. All right, so if I go through and I write all these coordinates, A prime ends up being 6, 1. B prime ends up being 8, 6. And C prime ends up being 4, 6. And if I compared it to A, notice how the X value stayed the same. The Y value went from negative 1 to positive 1. It changed signs. The original B was 8, negative 6. And again, the X's stayed the same. The Y went from negative to positive. So what's the rule? Basically, when you reflect over the x-axis, you change the sign on the Y coordinate. All right, so to go back and just recap, when you reflect it over the Y, you switch the sign on the X. So it's the opposite of what you would think. If you reflect it over the X, then you switch the sign on the Y value. All right? So basically, if you have a point XY and you reflect it over the x-axis, it's going to become P X negative Y, where you're changing the sign on the Y value. All right? We're not going to worry about all the corresponding sides and everything. All right? Try the next 3 questions. 3, 4, and 5. We'll talk to you soon. Bye-bye.